So this is the last problem dealing with partial fraction decomposition. So we have our expression over here, right? And again, we want to factor out the denominator. Well, it looks like here that the factors have already been factored out, right? We know that this is x times x minus 5 cubed. We have one distinct factor, and then there are obviously repeated linear factors here, right, with x minus 5. But we don't have to factor anything out, right? In the previous lesson, we did have to factor out that cubic expression, right, using the rational zero theorem and then synthetic division. But here we don't really require any factoring. We have a expression that has already been factored. So we can write this as a divided by x plus b divided by x minus 1 plus c divided by x minus 5 squared plus d divided by x minus 5 cubed. We have this expression over here, right? And so looking at this, well, we all obviously know that when we're adding these split fractions, right, obviously this must be equal to this expression over here, right, on the top. That's how we're going to split or decompose this larger fraction into these four distinct factors, right? But we already know that, so I'm just going to skip that step. Now what the next step should be is to realize that when we're doing this process of partial fraction decomposition, the denominator values must be set equal. So here we know that the common denominator must be x times x minus 5 to the power of 3. Well, then this must be a times x minus 5 to the power of 3 plus b times x minus 5 to the power of 2 times x plus c times x minus 5 and then times x, and then you have plus d times x. Well, now you know that this over here, this value in the denominator is equal to this value in the denominator, right? So you really can just take this out, right? That's what we wanted. So now you can set the numerators equal to one another, right? And then solve from there. So you have this is equal to negative 2x cubed plus 36x squared minus 199x plus 375. So I just copied the numerator here, right? And so now when I have this expression, the first thing that comes to my mind is that we can say let x be equal to 5, right? Because in that case, this goes away, this goes away, this goes away. We're left with 5d. 5d is equal to, well, now this next step would be to obviously put 5 into this expression over here, right? And so we can do that, and we get something like 5d is equal to 30. So therefore, you know, d must be 6. Your d value must be 6. Now we're looking at the a value, right? And so for a value, we can say that let x be equal to 0. I know that we can find the a value because I know that x here is in common in all these three factors, right? Dealing with b, c, and d. So when I say that let x is equal to 0, all of these go away and we are left with a's. So we have negative 5 to the power of 3. That's negative 125. A is equal to, well, if x is equal to 0, all of this goes away. Negative 125a is equal to 375. Therefore, the value of a must be negative 3. So we know that d is equal to 6, a is equal to negative 3, right? Those are the two values for d and a. Now we want to find the other values, b and c. And so there's no specific method, right? We can just go by trial and error and pick different values of x to establish our system of equations and then solve from there. So we do know our a and d, right? Which is obviously going to help us because whenever we plug in various values for x into the expression, we already know what a and d are, right? So we know here I can just say that a is equal to negative 3 and then d is equal to positive 6. So now for instance, let us just say let x be equal to positive 3, right? And so we can do that. So we obviously have 3 minus 5, that's negative 2. Negative 2 cubed, right? That will be negative 8. So negative 8a plus this becomes 4. This becomes so 4b times 3 plus 12b plus, well, now we're looking at c times this expression over here, right? So we said let x is equal to 3, so we have negative 2 times 3, negative 6, negative 6c here, negative 6c. right? And then we have dx. Well, we know d is already 6, and 6 times 3 is 18, and this is equal to 48. For just so I had more space here, I did erase the other expression, but when I'm getting this 48, I'm really just plugging x is equal to 3 into the numerator, right? Because we know that this over here, a times x minus 5 to the power of 3, all of this up to d times x is equal to this value in the numerator up here, right? So I just plugged 3 into this expression here and I got 48. And we can simplify this and we get negative 8a, right? Negative 8a plus 12b minus 6c is equal to 30. I know the value of a over here, but I just don't want to use it because I see another pattern here. Because if I say that let x is equal to 7, right here I said let x is equal to 3, and I got negative 8a. So if I say that let x is equal to positive 7, right, then I will get 8a here. So they're anyways going to eliminate themselves, right? They're not going to be there. So we don't really have to care about this value of a here, although we know that it's negative 3. So if we say that let x is equal to 7, we can plug this into the expression. We get 8a, right, plus 28b plus 14c plus 42, right, because 7 times 6 is 42, is equal to 60. So we have this now, and then obviously we can subtract 42 from both sides, so we get that this is really just equal to 18, right? So we have this expression over here, and we have this expression over here. The reason why I picked x is equal to 3 and x is equal to 7 is that they were both giving me that negative 8a and the positive 8a, and that's a good sign because now we can eliminate those, right? And so when I say we can eliminate those, what I'm really saying is that, well, we have negative 8a over here, right? So if we not even subtract, here in this case we would be adding these two equations, right, to eliminate the a's, because negative 8 plus 8 is 0, so we can do that. So this goes away. We add 28 plus 12, that gives us 40b, and then we obviously add negative 6c and 14c. Well, that's plus 8c is equal to 48. And we can further simplify this as 5b plus c is equal to 6, right? I divided both sides by 8, so obviously this becomes 5b plus c is equal to 6 over here. So we know that that could be one possible system of equations, right? Because obviously we don't care about the value of d because we already put the value of d. We could have put the value of a as well. I just preferred getting it right over here. So now we know 5b plus c is equal to 6, right? This is one of the system of equations we have. So I can resolve this. Right, and now I did take let x is equal to 7, so I could also say that let x is equal to 8. I don't know, I'm just picking that value, and so obviously now we know that here we can plug x into the equation, right? So that would give us 27a plus, so it would be 3 squared, 9 times 8, so 72b, plus we would have 3 times a 24c, and then plus 8 times the value of d, which is 48, is equal to 63. Again, plugging 8 into this expression over here, right? And so we can solve this, but here, just for the sake of it, I would just prefer putting a in here, into a here. So 27 times a, right? That is negative 81. Right, 27 times 3. So we can obviously take that and add that to 63 and then subtract 48 from that. So we're going to be left with 72b plus 24c, right? So I can just do that. So we can subtract 48 from 63, right? So we get obviously 15, and then we have a negative 81 here, and we want to add that 81. So we're left with 72b plus 24c is equal to 96. Now we can divide both sides by 24, right? If we divide this by 24, we're left with 3b plus c is equal to positive 4, right? And we know one of our expression here, one of our equations here was 5b plus c is equal to positive 6, right? And that's a good sign because now we know that c's are common, right? So we can obviously use a system of equations, right? So again, you need to have strong algebra skills here just to solve this. So here we would obviously subtract, right? We can subtract the c, so we're left with negative 2b is equal to negative 2. So you know that the value of b must be 1. b is equal to 1. And if b is equal to 1, well, 3 times 1 is 3, subtract 3 from 4, c must then also be equal to 1. So you have your a value, your d value, your b value, your c value, right? So your final answer to this problem is, well, you know a is negative 3, right? So you can write negative 3 here. You know your value for b is positive 1. And then you know the value for c is also positive 1. And then the value for d is positive 6. Right, so when we're writing it, we're just putting those values back in. So our final answer is this, negative 3 divided by x plus 1 divided by x minus 5 plus 1 divided by x minus 5 squared plus 6 divided by x minus 5 cubed. So thanks for watching.